So thanks for guys for waiting and join us for this workshop. And we are very happy to have Bodgan, who are the CEO, co-founder and the CTO of the Tenderly, and he will be sharing how to use fantastic metrics to monitor your Web3 projects. Yeah, that'll be it for that's it. And I won't talk anymore and give the mic to Bogdan. Feel free to begin when you're ready.
Awesome. So hi everyone. As already mentioned, my name is Bogdan and I'm the co-founder and CTO of Tenderly. You can think of Tenderly as an end-to-end developer platform for blockchains that look like Ethereum, so smart contract enabled blockchains. We basically help developers and people building on top of compatible blockchains from the moment they come up with a particular idea, and then from the development process all the way to production with a bunch of different services. So with monitoring, alerting, debugging, a bunch of APIs that help you do a lot of interesting things, and I'll show you that a bit later. But this workshop today is basically focused on two things. One of them is what is monitoring in general, and when we cover that, and then the second one will be a really quick demo of Tenderly to see if you guys can benefit from this, especially during the hackathon. So why the question mark here? Basically, while working on Tenderly for the past 3 years, we discovered that monitoring is much more important in the Web 3.0 world than in the Web 2.0 world, because as we all know, it's almost that it feels like each week we have a hack that has taken multiples of millions of dollars, or an exploit that breaks a dApp completely, or similar things. So monitoring is one of the ways to be sure that none of that happens, or at least to mitigate the chance of that actually happening. So as we mentioned, I come from Tenderly, and this is my Twitter handle if you want to shout at me during the presentation. And originally this talk was actually called Fantastic Metrics and Where to Find Them, although it wasn't really that self-explanatory. So that's why the metrics won from the beginning of this call. So without further ado, we'll be covering three things at the first part: what is monitoring, when to actually start monitoring, and what does monitoring mean for dApps and protocols. So for the first two will be more from the perspective of Web 2.0 world, as we can learn quite a lot from them. And then after that, we will see how to actually use that in the Web 3.0 world. So if you do the standard thing and Google a term, you will come up with a Wikipedia page where it says that monitoring is tools and processes by which you measure and manage your IT systems. And I highlighted the tools and processes here as I think they're the only important part of this sentence, and let me explain that a bit more. So how I at least love to explain monitoring is that it's basically metrics or some data generated by the system, in this case our application, from which we can get some business value, because in the end we are engineers, but we do need to make some business value to basically earn a living. Making things is fun, bringing value to other people is even more fun. So we can see two main words here that pop up. That's the business and the system side of things. And we'll cover what does monitoring mean in both of these contexts. So from a business perspective, metrics is basically user experience data. An example from the Web 2.0 world is how many times a particular button was clicked, or how much time does it take to come from adding something to a cart, for example, and then going to checkout, and similar things. So you can think of it as measurable things a user does on your website, app, or whichever product you're building. Those metrics are used for product decisions. Now, building products is fun. We all definitely have that some intuitive way of thinking of what users might actually like to use and how to use it. But having data to make decisions is much easier, because you're not going in blindfolded into those decision meetings. You actually know how people are using, or not using, even worse, but how people are using your product, and you can make decisions by using that particular data. And it's used for technology investments. We all know that the business people basically when they make decisions, you look at it from a product perspective, but at the end of the day, those are actually technology investments. So it's taking into account what will engineers do for the next 2 weeks, 4 months, 6 months, a year, or whatever. So that's basically a technology investment, even if it's looked upon from a business context. So that's basically the business side of things. And then the system side of things might be more interesting to people on this call. So for the system side of things, the first thing is the state of the system. So again, in the standard Web 2.0 world, this can be, for example, monitoring is usually used for monitoring servers. For example, this can be the number of open file descriptors, or the amount of RAM being used right now, or the CPU utilization of a server. So that's basically some really system level things, the state of the system itself, that we take into account when looking at the particular thing. Those aren't made for making business decisions, but they're actually really good to be found when making, just give me a second here, when to detect problems. So if something goes wrong, we can use system level metrics to find who the culprit is much faster. And then, as we mentioned, after we detect the problem and see it, it's much easier to actually come up with a fix or the correct way of handling things, because we can use those metrics to diagnose those faults and resolve them. So that's one thing from the business perspective, and then from the system perspective. So when we kind of now covered what is monitoring, but it will be even more apparent when we cover when to actually start monitoring. So we can think of 3 levels of monitoring, or 3 points in your project's life when you can start monitoring. The first level of monitoring is manual. The second one is reactive. And then the third one is proactive. Now, what does this mean, except only nice words to say? We can cover a couple of things about each of them. So the manual way is we check periodically. Imagine you shipped your dApp, so you finally deployed your dApp to Polygon, or your smart contracts to Polygon, and then imagine for the manual monitoring to wake up each morning, open up Polygon scan, and refresh the contract page for each of your contracts to see if something went wrong during the night. We can all agree that's quite stressful, as you don't know what happened. Plus, it kind of leans on you to actually check them. Imagine if you're on a long flight, or I don't know, don't have access to the internet at that particular point in time. It's really bad for you to be the source of failure for a particular check. The second thing, which might be even worse, is that when something goes wrong, you're almost always notified about that by your user. So when something goes wrong, you get the user saying, hey, guys, this isn't working. Can you please fix it? That's a bad user experience because something didn't work for the user. But what's even worse is that for each user that actually does report a problem, there's probably a dozen more who did see the problem and just didn't want the whole hassle of reporting something. So that's another problem there. And then it's usually people start checking things manually after something fails, or only for a particular part of the system that we don't feel confident about. So again, what does this mean? Something doesn't work, and then from that point on, we will periodically check if it's working or not after the fix. Or let's say we see a part of the system that we perceive as important in the Web 2.0 world. That's, for example, billing systems or similar. And then we only check the logs of those systems and similar to see if everything is working as expected. That's really bad because, again, we're the source of failure. Now, where most projects land after some time of existing is the reactive approach. So the reactive approach is based on simple thresholds. Again, in the Web 2.0 world, you can be alerted, for example, if more than 80% of your RAM is used, or if you're approaching the limit to having too many open files on a particular server. Here we can see that threshold, a simple one, for example, the number of outstanding loans in your DeFi project, as an example, or ERC20 balance of a particular address being going below a certain limit. That can be a simple threshold you can check. It is some movement towards using data for measuring customer experience. So this should be contrasted from the user experience. Customer experience is basically everything around your project. So you can proactively measure if your users, or customers in this case, are getting the exact value you wanted to give them while building your product, basically. So this is good, as you're now finally measuring something and you can incur some data from those measurements, but it's still probably not enough. Again, why it's called reactive. Updates to these monitoring systems usually tend to be reactive in response to an incident or outage. So similar to the manual approach, we will actually start monitoring only when something has gone wrong for the first time. Let's say a part of our system breaks and then we add monitoring there. Or for example, what unfortunately usually is the case in the DeFi ecosystem, there's an exploit found and only then people actually start using monitoring solutions. And again, only for those particular parts of their system. Basically, that's why it's called reactive, because only as a reaction to a certain event, usually not a happy one, we start actually to monitor things. And again, this is the thing where we built out we thought out our product. We made some business decisions. We have made our applications, stood up our servers, deployed our smart contracts and everything else. And only then we're actually starting to think about monitoring as a thing. So only then it comes to our mind, hey, I might want to get notified if something goes wrong, or hey, I'm really interested in this particular analytics thing to know how my system is performing. So because it's an afterthought, it's much harder to retroactively fit a monitoring solution or analytics solution on top of your product, just because you thought about it at the end and not at the beginning. So we come to the holy grail of monitoring, which I'm guessing not many companies do. So the reactive and proactive approach, somewhere in between, to be completely honest, is the correct way of doing things. But the proactive approach is basically, you see monitoring as a core to managing your infrastructure and the business. So the business doesn't make business decisions, the system or the programmers, developers, engineers, product builders don't actually do anything unless they have monitoring in place, because only then we're all feeling comfortable in making decisions, both from a business and a technological perspective. The second thing there is it's also used, the focus on the proactive approach is to measuring the application performance and the business outcome. So if you remember from the beginning, we had the business and the system metrics. Basically, you have different personas in your team being interested in each one of those. Only when you're doing, not only, but when you're doing the proactive approach, you're thinking about everybody's needs, because marketing doesn't care about the same metrics the engineers care about, who don't care about the same metrics about the business development team, for example, cares about. So basically, during thinking of everything, you take into account each person that might have a look at those particular metrics. It is the main focus of measuring the quality of service and customer experience. So again, you're not in the dark at this point. You know that the service or value you're providing to your users is the one that you thought about. You can be sure that it's actually the one that you want to give up to a quality standard that you have set for yourself. And finally, you can be sure that the customers are experiencing your product as you wanted them. Or if not, at least you know when and where to iterate, basically. And then finally, this one I think is definitely the most important one. So a product or a feature cannot be considered complete or ready for deployment without monitoring. So the correct way or correct feeling or emotion to get basically when you're doing the proactive one is to basically feel scared to deploy something until you get monitoring in place. At that particular point, you can be sure that if something isn't working, you can get to the source of the problem extremely quickly. You can be sure that if you want to iterate on a particular feature or product, you can be sure that you have more than enough data to make those decisions. And then finally, you can be sure that your system is performing as expected because you have everything set up in place for it to actually work in that way. So again, the most important thing to take from this presentation, maybe this whole presentation, is that products will not be considered feature complete or ready for deployment without actually having all of this in place. So we covered what is monitoring. We covered when to start monitoring and the 3 levels of monitoring. Basically, the third one is, what does this mean in the Web3 ecosystem? So I can show you later this in the dashboard. Unfortunately, this is a PDF, so the videos won't work here. But the first thing you can see here is gas usage. Gas usage is basically, as we all know, submitting a transaction on chain, be it on Polygon, being on Ethereum mainnet or whatever, you're spending users' funds. So you need to be sure that you're spending only the minimum needed for your smart contract to actually work. And basically, by monitoring gas usage or considering gas usage as a metric of your monitoring system, In that way, you can be sure you can optimize your smart contracts to spend as less gas as possible. The second one, and here we're missing a video basically, but this is optimization comparison. So once you actually do those optimizations, you have two versions of your smart contract deployed to Polygon. You can be sure that you can compare that the newer version is actually performing better than the last one. Here we have protocol version comparison. This is basically comparing if your product is, if the newer version of your protocol is working better than the last one. And by better, I mean more users using it. A good example there, if you're making an AMM, here you can measure if all of the LPs are migrating their funds to the new version. Here you can see if the retail customers are actually performing more swaps on the newer version than the last one. And in that way, you can be sure that the incentives you set up in the newer version are better than the last one. And by incentive, we come to the next thing that we can cover. It's basically measuring the incentive system you have put up in your place that you probably ideated in a white paper or whatever. Measuring the metrics or gathering data in your system to see if those incentives are actually performing as you expect them to, and that the people are actually doing it, are using your protocol or providing liquidity or whatever your project is doing because of all of the value that you're bringing to them, basically. Emitted events, this is basically a metric that it can either have a lot of noise, that's the first one, but it can also be really good for detecting outliers. So basically just shoving in all of your contracts and monitoring which events are being emitted the most. This is extremely useful. This is extremely useful to see if a particular event is being emitted more, or it can be just used as a heartbeat of your system. Again, if you're if you're doing an AMM, just monitoring for the swap event is more than enough to see if people are actually using your product. This is the same one, basically just looked upon as a table. Function calls is a really interesting one. So this one can actually be really cool for detecting a possible exploit when somebody's calling a particular function more than others. So again, similar to the emitted events, not all functions need to emit an event for you to actually see which part of your smart contract or which smart contracts are being called the most. So the function calls one is a really good one to monitor as well. Outlier detection. This is basically taking all of the addresses that are calling your smart contracts, counting them or aggregating them by the caller, and then looking at who is calling your smart contracts the most. At that point, you can see that you either have super users, that's one of them, or have a lot of bots using your product. But finally, you can also do exploit detection by using this because you can see a particular address is spamming your smart contract. Maybe it's draining funds. It's really good to look at it at that point. So things to take from the first part of this presentation is to definitely monitor from day one. The second is that even though we're mostly engineers, it's really important to take both the business and technical metrics into account while building your system. And I'm guessing be proactive, not reactive. So try to think in advance what will be useful for you, add metrics around all of that, and then you don't need to react downstream or down the road. Basically, you're all good to go to make decisions and diagnose problems efficiently. That's basically the end of the first part of this talk. I don't know if we have any questions. If not, I can move on to the demo.
We can move to the next one.
Sure. Just give me a second to open up Tenderly here. And let me reshare my screen. If you can just say if you see the user interface now.
Yep, clearly.
Awesome. So Tenderly is basically consisted of multiple projects. You can think of a project as like a group of smart contracts you can do something around with. An easy thing to actually try out. I'm here using the mainnet, but we basically support the Ethereum mainnet, all of the testnets, Polygon and the testnets, Binance, Binance Smart Chain, Avalanche, XDAI, POA, a couple of more actually. Optimism from fairly recently, and RSK. So we do support a lot of networks. So almost anything that's CVM compatible, we supported, with support coming soon for FTM and Arbitrum, basically. So without further ado, I'm going to get the, I like the Kyber Network Proxy contract to demo things. So let's create a new project. Let's do Polygon. Let's call it like that. And basically I can add the contract. There's a couple of ways I can import it via the UI. We also have a CLI and a Hardcat plugin as well. And then finally here, you can paste in an address. By pasting in the address, we'll actually check all of the explorers that we support for. So for example, Polygon Scan and the rest, and we will automatically detect that contract and import it into your project. So after the import is done, we can see here that when I go to the transaction screen, I see all of the transactions listed. We can see that this one was used 5 days ago, the last time. And then if I have multiple contracts added here, we will basically show all of the transactions aggregated here. So the first thing that we can do is we can filter transactions. So I can, for example, say, give me all of the failed transactions for my Kyber Network Proxy contract. And then basically after the search is complete, we can see here all of the failed calls, and there's not a lot of them, which is really good for Kyber Network. So let's go here first to this one, which is trade with hint, which failed. The first thing people actually usually find Tenderly for is the stack traces. So if you go to a failed transaction and once it loads, this one used a lot of gas, so the tracing is taking a bit more time. Basically, after this is rendered, we can see a full stack trace here of where something went wrong. So I don't need to guess where this particular piece of code resides in. I can see that it failed here. And I can even jump into the debugger experience here and see all of the state local variables and the rest and see why it actually failed. So this is really interesting. Now, if we go back to the transaction listing, let's just open up a successful transaction here. So let's do a direct one. There haven't been a lot of direct ones. Let's give me a second here. So let's do all of these successful direct transactions to Kyber Network. Give it a second to filter out. Here we go. We have a trade with hint here that actually succeeded. It used up 1 million gas. So again, we'll need to wait 5 seconds for a full trace to happen and for my browser basically to render this, which is a bit slower when you're sharing a screen over Zoom. Here we go. So we can see a lot of things happening here. We can see the decoded input data. We can also see the decoded output data for this particular function call here, trade with hint. We can see all of the token transfers basically that happened as well in this particular transaction. And then we have something here which we call the execution trace. This is a graphical way to see all of the things that happened during a particular transaction. And again, if you remember the debugging experience, so at each point in time, I can just click here, click on view in debugger, and suddenly we have the access to the contract caller, input, output variables, state variables if they're used in a particular call as well. And we can go around in this trace, jump around, go up and down the stack trace as well. We can see the output and the rest. So basically, you can have a normal debugging experience you would expect from a programming language in 2021 for every transaction that happened. The second thing I would like to say here is that you can see all of the contracts here that participate in this particular transaction. A good thing here is basically this kind of illustrates the whole money Legos analogy being used in DeFi, where you see a bunch of protocols talking to each other and lending, borrowing from each other and the rest. Another thing here we can see is basically all of the events that were emitted during the transaction. Again, on a normal Explorer, you would probably see something along these lines, which isn't really human readable. Here we decode everything for your convenience so you can be sure what happened. State change is a similar one to the events. So basically all of the state that has changed in all of the smart contracts in this particular transaction, we can basically look at it and see the old value, the new value. We also support mappings as well, as you can see here. So this is a mapping of an address to an address to a UN256. So basically, it's really easy and convenient for debugging as well. We saw the debugger, and then finally the one, if you remember from the presentation itself, is the gas profiler, where basically we can have a deep dive into all of the things that happen into transaction, how much gas it actually used, and then we can see here the certain points that we might be able to optimize our gas usage, which is very, very useful. Anywho, so moving on to the next part of Tenderly, you can see the Resimulate button here. So when I click this, we will jump to our simulator experience. Now, because in Tenderly, how we work is we basically have our own version of the Ethereum virtual machine, which is also used by Polygon for executing those smart contracts. And we can hotwire the EVM into thinking that it's executing an on-chain transaction. So now when I click Resimulate, here we have all of the input data that was actually used for this particular transaction. So if I click on simulate transaction, oh, I haven't put a good gas value here. I will even change the parameters a bit. So basically, we need more gas for this particular address. So basically, if I change this particular transaction, I can use the default address and this should pass. Here we go. This fails now here because it doesn't have the balances from the from address is 0x000. So that's why it didn't work. But basically, I can change the parameters of this particular simulation or transaction and see what would happen if I changed what it does on chain. An extreme, and this can basically work for any function in the contract. Now, what's even crazier is that we can, for example, go into edit contract source, which even this might be even more fun. So we see that in Poly token line 147 is the actual reason why this particular transaction fails. So let's say this was a bug, even if it wasn't. I can take in. Sorry, I need to copy the address here. Here we go. So this is the address here. Now, when I click on Resimulate, I can add the contract that I actually picked. Here we go. We see it's the Poly token. And now we know that on line 147, we have the line here where it broke. So I can comment out this line. I can say apply changes. There we go. And now when I simulate the transaction, we can see it failed on the next line. And the reason for that, as you can see, in the simulation, this one was commented out. So you can basically even change the source code of a particular contract when wanting to test out something. That's the simulator. And we also provide this via an API. So you can simulate pending transactions, you can change historical transactions and similar things. Now, when you look at the simulator, the logical thing to think is, can I chain multiple simulations together? And the answer is yes, and this is what the forks feature is. So I can say fork a network and I can pick Polygon. And let's say I want to use the latest block. So this is my Polygon fork. Now, when I create this, suddenly I have my own version of Polygon that I can also use via JSONRPC, which I can deploy contracts to, also verify as an example as well. Or I can have the same simulation experience that we just saw. I don't have a Polygon contract here, so that's why it's not showing the Kyber network one. But basically get the same simulation experience only by chaining multiple simulations with each other. And again, this has a JSON-RPC endpoint as well. So a lot of people are using this instead of a local node. Even they're using it for testing and forking mainnet. And the simulator and the forks have numerous use cases, and I definitely encourage you to try things out and come up with ideas because it can be really, really useful. The local transactions here is basically the same experience you saw when I clicked on a particular transactions or when simulating, only for your local transaction. So basically you can use our CLI while you're developing locally, do Tenderly export and the name and the hash of the transaction, and suddenly you will get back a unique link, which you can use to basically use all of the tooling that you just saw now during local development. Next thing up is the analytics here. Now, the analytics is really interesting because we do everything all demand. So nothing all of this is cached. So I can, for example, say, tell me the average gas used per function call per contract, although we have only one contract here in the last, let's do 7 days and break that by the hour. And this wasn't definitely used a lot in the last 7 days. Let's do something else. Let's do last 90 days. And then as you can see, this was all done instantly. We can see how much each function was called. You can see trade with hand was called quite a lot at each particular hour. So that's very powerful as well for some system level, system level metrics. And then finally, we come to the alerting feature. This basically gives you a way to get alerted on email, Slack, Telegram, Discord, Sentry, and PagerDuty when something happens. So when a particular rule is matched. What does this mean? We have a bunch of alert types here. There's standard ones like successful and failed transactions. So you will basically get an alert when the transaction succeeds or fails. We have one here when a particular function is called, you can get alerted. And this doesn't even mean the direct one. So even mid transaction, if something happens, you can receive an alert. The event emitted is basically get an alert when a particular event is called. I'll show the event parameter later because it's really interesting to see. DRC20 token transfer alert, whitelisted and blacklisted callers. So basically providing a list and then getting alerted if a particular address is in it or not, depending on which one you picked. ETH balance is basically the native change balance or currency. When it falls under a certain threshold, you get an alert. Same for transaction value. So if the value of transaction is more than X, basically get alerted. And then state change and view function, which are really interesting. So the state change, when the state changes in a particular way. Let's pick here. I'm not sure if the Kyber network proxy will be an interesting one. Yeah, let's take another contract here and add it to a project. Let's do DAI so we can monitor the supply. So if I go to add contract now, add DAI over here. We can go to alerting now. And then I can say, if the state of the DAI contract, and then let's do total supply, changes by more than 30%, alert me on, and then I can pick any of the destinations basically that I support. And I will get real-time alerts the moment this transaction hits the chain. And then the similar two ones that we can see, because we have 6 more minutes, basically one of them is the view function. So again, I can pick the DAI contract here and then say if the balance of a particular address, so let's do, I don't know, this isn't going to be valid, I'm quite sure. Here we go. If the balance of this particular address returns, I don't know, more than this amount of DAI, oops, sorry, send me an alert. Again, we can do a percentage change or the threshold that is passed. And we basically check this on each block and we make sure that if this criteria is matched, we will alert you. And then finally, maybe the most used one is the event parameter. Again, by the way, I can monitor by network project and tag as well, but we're using contract here as this. It's the simplest one to explain. Again, we can say when DAI does the transfer event, and then the destination is this, oops, sorry, is this particular address, send me an alert. So the alerting is very flexible. You can do quite a lot. Receive notifications in the middle of the night. I mean, God forbid, but again, get notified in the middle of the night if something isn't working as expected. And yeah, that's basically a really quick demo of Tenderly, which is much bigger than this. So I'm guessing we have 5 more minutes for questions.
Definitely. Let me check. Well, I don't see too much questions coming up. I guess probably it's like a very, I guess it's a bit hard to understand for people like me without a technical background. Yeah. But I guess I could ask a few questions, but more focus on the business side.
Sure.
So maybe do you want to tell us like what gonna be the next big move for the Tenderly in the future?
Sure.
Yeah.
Sure. So we're definitely always expanding to new networks. That's one of the things that I mentioned. So that's basically driven by customer feedback. So depending on when people ask for something. But I think the more interesting thing is that we're revamping the debugger experience. So a thing that you will probably this is again a technical thing. Sorry, I just realized.
Yeah.
But yeah, other than from the business perspective of expanding the team and everything else, it's basically giving you a way to, with the new debugger experience, change everything you want about the debugger. So it's the experience you want. So even checking if a particular variable is something in the middle of the transaction. So getting a fully fledged debugger ship base, that's basically it. And then from the one that comes to mind the best from the business perspective is we're revamping our pricing as well. So that will be really interesting. And this is more of a tease than a concrete thing to say. So that is definitely an interesting thing to look out for.
Okay, sounds interesting. Yeah, I don't think I could come up with more questions actually.
It's completely fine. Then
Yeah, I mean, yeah, probably it's because today is the like a Chinese traditional festival, so people are
sure.
going back home and chilling with family, don't work watching the workshop. Yeah.
I'm guessing.
But anyways, really appreciate your workshop today. I believe if any developers watch your workshop, it could be really helpful for them to if they want to build on Ethereum based whatever chains using Tenderly. Yeah, really appreciate your efforts and
Awesome.
yeah, so I guess that could be it for today, and thank you very much. So for our audience, if you haven't followed us on YouTube and Bilibili, please make sure you do that so you won't miss out any of the upcoming workshop and project demo sessions in the future. And hope you're all doing great building on the Polygon network. And thank you very much and good luck. By the way, happy Mid-Autumn Festival, Bodgan.
Thank you.
Yeah.
Awesome. Nice talking to you.
Yeah,
Bye-bye.
everyone. Bye-bye.